Everyone, this is lesson 8.4, word problems. Today we're going to learn how to create word problems or equations for a word problem and solve for the missing variable. So number one gives you a display of your school library that sits on top of two rectangular tables arranged in an L shape as shown. So the tables have the same area. So the area of this is equal to the area of that. Okay, so whenever they would say that, then the equation is probably going to be something like whatever the expression for this area is equal to the expression for that area. So like A1 area of the first one equals the area of the second one. Okay, but now we are going to write the equation in terms of W, in terms of the width. So let's think about what the length and the width would be for the first tabletop. So the length is this W plus 2. So W plus 2. And then the width is W. So I'm going to multiply that like this, like monomial times binomial. Right? And then for the other one, the width is W, or the length. Width and length can really be interchangeable. It doesn't matter too much. And then the length, well, if the whole thing is 10, but this part is what we're trying to find, then we're going to say 10 minus W, take away this part here, and that gives us the length of this table. So we're going to say 10 minus W. All right, so then I'm going to put this all into an equation. So W times W plus 2 equals W times 10 minus W. All right, so that would be an equation that would relate the two areas of the tabletops. All right, so now what we're going to do, if we want to find the value of W, then the idea is to get your equation equal to 0 and use the zero product property that you learned last week. So in order to get the equation to 0, we're going to have to simplify, get rid of the parentheses. So the first step is to distribute or FOIL. In this case, just distributing would be the correct method because we don't have binomial times binomial. Okay, so we'll distribute the W into the parentheses from both sides. So we get W squared plus 2W for here, and then equals 10W minus W squared. All right, so now we're going to move all of the terms over to one side. So move terms to one side. All right, so I'm going to add the W squared over. And W squared plus W squared is going to give us 2W squared. And then I'm going to subtract this 10W over from the 2W. And that would give us negative 8W. And then now there's nothing left on this side, so it equals 0. And now we can factor to use the zero product property. So step 3 is to factor. So we can factor out a 2W from both of these terms and get W minus 4. Right? And then the last step would just be to solve. So this factor would give us W equals 0, and the width can't be 0, so we would discount that one. And then this factor, if we set that equal to 0, we would get W equals 4. So W equals 4 would be the solution for part B. Now part C, if you go back up to it, it asks what's the combined area of the tabletops? So what you would do then is you would plug 4 back into either one of these. So if we did this one, 4 times 4 plus 2 would be 4 times 6, which is 24. Now what if you did it for this one? You would get 4 times 10 minus 4. 10 minus 4 is 6, and you get 24 again. So then they should be the same. That's what we would expect to happen. So then the combined area would be 48 feet squared. All right. Next question. The shape of an arched doorway is modeled by the graph of the function y equals negative 0.5x times x minus 8, where x and y are measured in feet. On a coordinate plane, the floor is represented by the x-axis. So it says coordinate plane. So let's go to Desmos and let's get an idea of what this looks like, because I think that's really important to see what this graph looks like and how it's actually modeling an arched doorway. So let me pull open Desmos. So I'm going to type in the equation y equals negative 0.5x. And then the next part is times x minus 8. All right. So here is the arched doorway. So if you look up at the top, so the way that these quadratic equations work is they go up and then they come back down. Okay, and if you scroll out, it goes down for infinity, but it only reaches a maximum height, or sometimes it's going the opposite way and it reaches a minimum. So that maximum height, if we click here, that would be, now the maximum height occurs at 4 feet, or yes, we're working with feet. And then that maximum height is the y value, which would be 4. So just to emphasize, if this is 4, 8, this is where the maximum occurs at 4 feet, and this is actually the max height, 8 feet. Okay, and then it starts at 0, and then it goes to 8. So 8 feet would be how wide the doorway is. So let's go back to the question, how wide is the doorway at its base? So what we can see from the equation, the base is when the height is 0, or the y value equals 0. So if we set this equal to 0, that means we're solving for x and y, solving for x. So this 0 would be x equals 0, and this 0 would give us x equals 8, which is also what we confirmed on our graph. So how wide is the doorway? 8 feet. And then how high is the highest point of the arched doorway? So one thing about parabolas is that if the x's are between 0 and 8, the maximum height occurs halfway between those. So the max, or the min, if it's flipping the other way, is halfway between the zeros. So if 0 and 8 are the zeros, our maximum height would be occurring at 4 feet, which we saw on the graph. So in order to find the highest point, if we didn't have Desmos or our graphing calculator, we would just have to plug in 4 into our equation. So y equals negative 0.5 times 4, and then times x minus 4. So negative 0.5 times 4 is negative 2, and then, oh, I'm sorry, this was 4 minus 8. 4 minus 8 is negative 4. Negative 2 times negative 4 is positive 8. All right, so next we're going to learn about the vertical motion equation. So this is a really important equation that we're going to be using all throughout this unit. So the vertical motion equation, so imagine if I throw something, if you take an eraser and you throw it up into the air, it kind of follows this arch. Okay, if you throw a basketball, it follows this arch. It reaches a maximum height and then it comes back down in such a way that the same way it goes up is the same way it goes down. Okay, so these, if you were to actually like draw on a line of symmetry through the middle, it would be symmetric on both sides. So our vertical motion, we have an equation, a quadratic equation that relates the vertical motion to time. So where the x is the height and t is the time. So that equation is h equals negative 16 t squared plus vt plus s. So please make sure you write this equation down and what all of the variables mean. So h is the height of the object in feet. T represents the time in seconds. Now the reason this negative 16 here, that's like a gravity constant. If you were doing this in science class, he might explain it a little bit better than me. But the reason it's negative is because the vertical motion equation, the parabola is opening down. Okay, so this is called a parabola, the shape that this makes, and it's opening down. So that means that this first term is negative, kind of like a negative slope. And then V stands for initial velocity, the velocity at the beginning. Now, if you were to take an object and drop it, you aren't throwing it with a force, so the initial velocity would be 0. So V equals 0 when something is being dropped. And then S stands for initial height. Or you could think of it as like initial starting point. And if it's coming from the ground, the initial height will be 0. So S equals 0 when it comes from the ground. All right, or if something jumps from the ground. Okay, and then there's a supplementary equation to this that would be in meters. So this is the same thing, just the negative 16 is different. So for meters, you have H equals negative 4.9 t squared plus VT plus S. Okay, and these equations will be given to you, but it is helpful to have them written down and what everything means. Okay, so let's do number 1. Soccer ball is kicked upward from the ground with an initial velocity of 3.6 meters. So for this one, the equation would be H equals negative 16t squared. This part will always stay the same, plus the velocity is 3.6, so 3.6t. And then it's being kicked from the ground, so S is going to be 0, so we're not going to have anything at the end. After how many seconds does it land on the ground? So when it lands on the ground, that's when H equals 0. So what we're going to do to solve this is set our equation equal to 0, factor, and solve for t like you would in yesterday's assignment. So 0 equals negative 16t squared plus 3.6t. Okay, so whenever you have a negative in front, you're going to factor out the negative, which means you flip the other sign. So what else does 16 and 3.6 have in common? I'm not out. Oh, hold on a second. This was in meters. I'm sorry. So we should use 4.9 here. All right. So I'm not thinking that 4.9 and 3.6 have anything in common. Maybe they do, but we can actually just pull out a negative t. So 0 equals negative t times 4.9t. And then remember, if we pull out the negative, we're going to flip this sign to minus 3.6. So this would give us t equals 0. That's the beginning time. T equals 0 is the starting. And then this, if we set this equal to 0, we add over the 3.6, divide by 4.9, and then 3.6 divided by 4.9 gives us 0.73 seconds. So that's how long it takes the ball to reach the ground. And that's a pretty reasonable answer, right? Because, the ball should not be in the air for very long. You would expect it to come back down pretty quickly. So what is a reasonable domain and range for the function? So for the domain, you would say between 0 and 0.73 because that's the amount of time it takes to start and then reach the ground. And then for the range, let's consult our calculator for this question. Well, actually, yes. So for the range, it starts at 0 because that's the ground. It can't be negative. And then we're gonna figure out what the maximum height is. So to figure out the maximum height, there are a couple ways you could do this. You could divide 0.73 by 2 and plug it back into the equation. Or you could use, I'm going to show you how to use the Desmos way to do it. So let's do negative 4.9 t squared plus 3.6t. Okay, so here in Desmos, it shows you what the maximum height is, which is, in this case, it would be halfway between the zeros at 0.661. Okay, so we'll write all of those decimals. So it goes to 0.661 meters. All right, let's do another one. The cat leaps from the air into the ground with an initial velocity of 11 feet per second. So this one is kind of the same. So the equation would be h equals, and this is feet, so negative 16t squared plus initial velocity is 11t. The cat jumps from the ground. So after how many seconds does the cat land on the ground? You would set your equation equal to 0. Here I can just factor out a negative t. And then I'm left with 16t, flip the sign, minus 11. So that gives us t equals 0 when the cat jumps. And then if I solve this and set it equal to 0, I get 0.6875 seconds. Okay, I'm doing this one real quick because I want to get to the last question. All right, how about a penguin? So a penguin jumps out of the water while swimming. The action is called porpoising. The height of the penguin can be modeled by that equation. So they're telling us the initial velocity of the penguin then would be 4.5 feet per second. And then where t is the time since the penguin jumped out of the water. Find the zeros of the function and explain what they mean. All right, so to find the zeros of the function, that means the values of t, or x, when h or y equals 0. So we set our equation equal to 0, and then we factor to solve. So here I can just factor out a negative t. Sometimes you can factor out more than a negative t, just depends on what the velocity is, if it has anything in common with 16. So then we get 16t, flip the sign, minus 4.5. Okay, so this 0 gives us t equals 0, and if we're explaining what they mean, then this is the beginning time. So that means the penguin, starts at a height of 0. And then this, if I set this equal to 0, 16t equals 4.5 divided by 16. And 4.5 divided by 16 is 0.28. So this 0 means that it takes 0.28 seconds for the penguin to land back on the ground. So it takes 0.28 seconds for the penguin to land. Oh, back in the water, not the ground. Back in the water. Okay, and let's say I wanted to find the maximum height of the penguin. Well, the maximum height would occur halfway between the zeros, which in this case would be 0.14. So max height occurs at 0.14 seconds. And if I plug 0.14 seconds back into the equation, let me show you how you could do this with your calculator. You just go negative 16 times 0.14 squared plus 4.5 times 0.14. The penguin's maximum height is 0.3164 feet. So 0.3164 feet. Alrighty. So that being said, that is going to be our last example of this lesson. You will get some more practice on tomorrow's assignment. Hope you guys have a great day.